identical surcharges are placed at ground surface at sites X and Y, okay, with soil conditions shown alongside and water table at ground surface. So there is water table at two sides, and that is starting at the ground surface. The silty clay layers at X and Y are, see, this is silty clay layer, this is silty clay layer, saturated silty clay layer, here also saturated silty clay layer. They are identical. Water table is also identical, surcharge is also identical at two sides. The thin sand layer is at Y. Other than this thin sand layer which is there in the site Y, remaining all things are same at X and Y other than this thin sand layer, and it is free draining with very large discharge capacity. This one is having very large discharge capacity, means it can discharge the water. Water can enter into this sand layer. Now if primary consolidation at X site is taken 36 months, what would be the corresponding time taken for the completion of the primary consolidation at Y? So you just have to find out what is the time taken for the primary consolidation for the same clay layer at Y, whereas the same clay layer is taking 36 months at site X. So now, in consolidation, one-dimensional consolidation theory, while deriving the equations, we'll be getting different factors: coefficient of consolidation CV, coefficient of consolidation CV, and time factor TV. The solution will be the solution of the partial differential equations which we get during the derivation of that concept. We get solution as capital TV, time factor, equal to CV into small t into d square, where CV is known coefficient of consolidation, which is constant for a soil, and T is time for consolidation. This can be at any point, like 10% of consolidation, 50% consolidation. According to that, you can give some time. T50 means 50% consolidation, T10 means 10% consolidation. So it varies. And D is the drainage path. So I'll explain what is drainage path. CVT by D square equal to TV. So CV is constant anyway, coefficient of consolidation. T also I explained now, small t. D is drainage path. So what is drainage path? Drainage path is, suppose you take any clay of fully saturated. So now there is sand here. So now, okay, now you are applying some load to consolidate this clay. And another condition is, suppose there is sand, there is clay, but there is no sand, this is bedrock. And another condition that let us see only these two conditions, you will understand. Okay, so there is load to consolidate. So now, so this is capital H, here also capital H. Now the water particle anywhere in this clay has to travel out of this clay so that clay can come consolidated. So now if there is water particle here, where will it go? It will go here, because sand is permeable. If clay particle is here, water particle is here, it will go this side, because there is a sand which can drain the water. So draining can happen both sides. So this is called double drainage. on both sides. Now the maximum path which is travelled by a water particle in this clay is what? Suppose if it is near to the surface, it will travel this. If it is near to this, if it is at the middle, it can go anywhere. But if you take middle point and above that, it will travel this side, which is less than h by 2. If you take any point below this, that will travel this side, that is also less than h by 2. If it is at this point, it can travel anywhere. The maximum distance can be travelled by a water particle is h by 2. So the drainage path is nothing but maximum distance travelled by water is called drainage path. So what is drainage path in the double drainage? In the double drainage condition, D will be height of the clay layer by 2. Whereas in single drainage, this is single drainage because water particle has to go this direction only. Because there is bedrock, it is impervious, it cannot go down. Though water particle is at this point, it has to travel all along this clay layer and it should go up. So what is the maximum travel? That is H. So D is nothing but H in single drainage condition. Single drainage condition. So anyway, the concept of drainage path is what? The maximum distance traveled by water in any clay layer is called drainage path. So that is D, and the time taken for the consolidation is T, and CV is constant for a soil, and this TV depends upon consolidation level. If consolidation is percentage of consolidation is same in two sides, then TV will be same in two sides. Now what is asked? So primary consolidation, in both sides you need to calculate the primary consolidation, means total consolidation, 100% consolidation. That means TV is same and CV is same. So now TV equal to CVT by D square, then T equal to D square by D square into TV. So this is constant. So then T is proportional to D square. So if you write Ty by Tx dy by dx whole square. So here what is given data? Given data dy and dx we need to know. So what is the drainage path in x? What is the drainage path in y? We need to find out. So what is dx here? This is bedrock, this is open area, so it can go out. So the maximum distance traveled by water particle is 10 meter here, because only single drainage. And here the maximum path traveled by water in this site y. See, this is drain, it can drain water, here also it can drain out. So in this layer, in this particular part top of the layer, the maximum distance traveled by water is 2.5 meter, because this total height is 5. So it can drain here, it can drain here. So maximum path is 2.5. Coming to this part, what is the maximum? Here bedrock is there, here sand layer is. So water particle has to travel all along this 5 meter. So the maximum path traveled by a water in this total layer is 5 meter. Okay, from here to here 5 meter. Whatever particle is in the upper portion 2.5, whatever particle in the down is 5, the maximum is 5. Okay, so dy is 5, dx is 10. So now substitute that, you need to find out. See, tx is how much? Tx is 36 months. The time taken for primary consolidation T is 36 months at 6. you have to find out time at y, that's it. So now ty equal to tx 36 months, dy 5 divided by 10 square, 5 2s are 36 by 4, 4 9s are, therefore ty equal to 9 months. Ty equal to 9 months. So answer is C. Thank you.